Hey guys, we're back. We're looking at shapes in the coordinate plane today. We're going to look at how to classify those shapes using some of the formulas that we already know. So here are some of the formulas that we're going to use: the distance formula, the midpoint formula, and of course the slope formula. We're going to use these today to look at this shape. Can you guess what it might be? It's a pretty easy one, but we want to start off this way so you can use the formulas as you're going along and kind of make sure that what you're doing mathematically makes sense. So we're going to find the segment lengths of each segment. So we're going to do AC, AB, and BC, right? So we're going to start with AC. My distance formula, I have plotted right here, so we can just plug it in as we go. So D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So I need to figure out what my coordinate points are for A and C so I can plug that information in. A is right here at x1, y1, so I'm going to plug that right there. And then C, of course, is still at x1, but now it's at y5. So I'm going to put that right there. Now all I have to do is plug this information in to my formula. So D equals the square root of, here's my x2 is 1, my x1 is 1, my y2 is 5, my y1 is 1, so I'm plugging that in here. So the distance of segment AC is the square root of 1 minus 1 squared plus 5 minus 1 squared. So I do the parentheses first, and I see 1 minus 1 is 0, and 5 minus 1 is 4. So the distance equals the square root of 0 squared plus 4 squared. 0 squared is just 0, so I worry about this here, and I have 4 squared is 16. Square root of 16 is, of course, 4. So now I'm right back to the distance of segment AC is 4. All right, I'm going to do the same thing for AB. Same thing. I already have the information for A, so what's the information for B? Now I'm at x5, y1, so I plug that information in. My x2, x1, my y2, my y1, and I have 5 minus 1 squared plus 1 minus 1 squared, the square root of that, equals the distance of AB. Plugging those numbers in and solving inside the parentheses, I have 4 squared plus 0 squared, looking very familiar. Square root of 16, still looking very familiar, and the distance of AB is 4. So I plug that in here. Now last one, I'm going to look at B and C. I already have my plot points written out here, so all I have to do is plug and play, right? So X is 5 minus 1, Y is 1 minus 5. Now I have the distance of BC is the square root of 4 squared plus negative 4 squared. That negative goes away when we square, so I have the square root of 16 plus 16, also known as the square root of 32. And we can simplify that down even further to 4 the square root of 2. So that was pretty easy, right? It's a little more writing, but it's a little easier to see as you go through. Now we're going to identify our segment lengths on here so we can just go back and look at them. So I have AC is 4, AB is 4, and BC is 4 the square root of 2. We already figured that out from the last slide. So we know we have a three-sided shape. Big hint here, that's going to be a triangle. If you already figured that out, great job. No. So now we need to know, is it a scalene, isosceles, or equilateral triangle? So let's look at what defines these, right? So scalene, nothing's equal. That's not true. Isosceles, two sides are equal. Well, that's looking good. And then equilateral, all sides are equal. Well, that's not true. So we know that. Two sides are equal. So we know it's going to be an isosceles triangle. Just by the segment lengths alone, we need not do anything else for that. But what if they ask if it was acute, right, or obtuse? Well, then we would need to figure that out. So we already know it's an isosceles. So we know that these two angles are the same. So we need to know if it's acute, right, or obtuse. So we can use Pythagorean theorem, or we can use slope. So let's look at Pythagorean theorem first. A squared plus b squared equals c squared when it is a right angle. If a squared plus b squared is greater than c squared, it's acute. If a squared plus b squared is less than c squared, then it's obtuse. So we just need to plug this information into a squared, b squared, and c squared to see what we would get. So I do that over here, and I have 4 squared plus 4 squared equals 4 the square root of 2 squared. I solve those out, I get 16 plus 16 equals 32. 32 does equal 32, so this is going to be a right triangle. Now, if you don't like that and you want to see how slope works, or if you just want to try slope, we're going to do it that way as well. So we're going to use the slopes of AB and AC to identify if this is a right angle. Here's my slope formula back from the second slide, but I embedded them in so you can see them as we go. Slope is y2 minus y1 over x2 minus x1, also known as the change in y over the change in x. So if I plug that in here for AB, I have my change in y over my change in x. So I have 0 over 4. 0 divided by anything is 0. So that's what I have there, and that looks right to me because it's a horizontal line with a slope of 0. Now I'm going to look at AC, and I have my change in y and my change in x, 5 minus 1 over 1 minus 1, and I have 4 over 0. We do not divide by 0. That makes it an undefined slope, which is a vertical line, so that also looks correct to me. So I look here and I say, okay, 0 slope is a horizontal line, undefined slope is a vertical line. Truly horizontal and vertical lines create that right angle. They're perpendicular. They create that right angle. So now I have a right angle and a right triangle, which I already knew because we did Pythagorean theorem, but this shows you that you can do it either way. So, any questions? Please message me on Etsby or on Remind. We can schedule a Zoom time for individual or a small group review, or we can just answer a question that you need if you have it in the message. Please don't hesitate to let me know if you are struggling with any topic. We can make a video specifically for that, or again, we can just do a small group review and we can solve those problems live. I want to make sure that you understand everything that you're learning, so if you have any questions, ask them. We'll answer them. That's what we're here for. Thanks. Bye-bye.